For centuries, robots were rigid, metallic tools, static, unchanging, and dependent on humans for repair. But what if robots could behave more like living organisms, able to adapt, grow, and heal themselves? Imagine a robot that isn't assembled but grown, and when damaged, heals itself without human help. This is no longer science fiction. At Columbia University's Creative Machines Lab, we're pioneering robots that can autonomously alter their own structure to meet new challenges. Inspired by nature's resilience, we aim to create machines that sense their needs and physically change themselves. This isn't just about making robots tougher, it's about making them physically smarter, able to solve problems beyond today's machines. The potential is enormous. Robots that can bridge chasms on distant planets or heal themselves in disaster zones. In these scenarios, self-growing, self-healing robots aren't a luxury. They're essential. We're not just building better robots, we're laying the foundation for machines that evolve alongside us. This is the dawn of truly living machines. The journey ahead will redefine what machines can be. Our future partners in exploration and survival may be robots that grow, adapt, and heal, just like life itself. The secret to self-growing, self-healing robots is what we call robot metabolism. Like living organisms, these robots manage their own resources, sensing damage or need and responding by physically changing themselves. Internal sensors monitor their structure, much like nerves sense pain. When damage is detected, the robot's brain plans repairs or growth, deciding where new material is needed. The robot then transports and assembles building blocks through its own body, similar to how blood delivers nutrients. Our Trust-Link system lets robots eat their own building blocks, directing them to where they're needed most. This process allows robots to extend limbs, reinforce joints, or patch holes, all autonomously. Robot metabolism gives machines a form of physical intelligence, letting them actively participate in their own creation and maintenance. Unlike traditional robots, metabolic robots are never truly finished. They're always adapting. This ability to self-sustain and self-modify brings machines closer to the resilience of the natural world. It's a leap toward robots that can thrive in unpredictable environments. To realize robot metabolism, we created Trust-Link Robots modular machines built from simple, identical building blocks. These links connect to form strong, versatile structures much like Lego or Kennex. The robot's body is a dynamic network allowing links to travel internally like a conveyor belt within its skeleton. When growth or repair is needed, spare links move through the robot to the target site, reallocating material as needed. Imagine a bridge that delivers its own beams to the edge. As it grows, our robots work the same way. This self-contained construction lets robots build and repair themselves in places humans can't reach. Trust-Link robots can also reconfigure, shorten a limb, extend an arm, or widen their base for stability. By rearranging their building blocks, they adapt to any task or environment. This simple, modular approach unlocks powerful adaptability for the future of robotics. Space is the ultimate test for self-growing, self-healing robots. Launching heavy fixed machines is costly and risky repairs are nearly impossible. Instead, imagine sending a compact Trust-Link robot seed to the moon or Mars, packed with building blocks. On arrival, it grows into antennas, solar arrays, or habitat frames, expanding from a small package into vital infrastructure. When damaged by micrometeoroids or harsh conditions, the robot senses and repairs itself, extending its lifespan. These robots can even reconfigure to cross crevasses or reach distant samples, adapting to alien terrain. No longer limited by fixed designs, robotic explorers can reshape themselves to meet the unknown. This adaptability could make ambitious space missions more feasible and resilient than ever. Disaster zones are chaotic and dangerous, perfect for adaptable, self-healing robots. Trust-Link robots can squeeze through rubble, widen for stability, and repair themselves if damaged, continuing their mission without delay. They can brace collapsing walls, create bridges over gaps, and make unstable areas safer for human rescuers. These robots don't just observe, they actively shape the environment, creating safe paths and mitigating hazards. After rescue, fleets of such robots could clear debris, build shelters, and prepare sites for reconstruction. Their tireless adaptability accelerates recovery and keeps people out of harm's way. In the most challenging conditions, self-growing robots become invaluable partners. They help communities rebuild faster and safer after disaster strikes. With self-growing robots, safety and control are critical. Growth is limited by a finite supply of building blocks. Robots can't expand endlessly or replicate uncontrollably. Strict programming and ethical guidelines prevent harmful actions and ensure robots obey human commands. Robots can be programmed to never alter their core systems or always respond to a stop command. Growth patterns are predetermined, much like DNA guides biological organisms. Continuous human oversight ensures every action is logged and reviewable. If something goes wrong, humans can intervene and correct course. By combining physical limits, ethical programming, and vigilant monitoring, we harness these robots' power safely. Robots that grow, heal, and adapt mark a turning point in technology. We're moving from static machines to dynamic, resilient systems inspired by biology. Robot metabolism and modular self-assembly are laying the groundwork for technology that's cultivated, not just built. The impact will reach medicine, manufacturing, and infrastructure. Imagine self-repairing bridges or factories that reconfigure on demand. Today's prototypes are just the beginning. Scaling up and refining intelligence are the next challenges. The fusion of material science, AI, and engineering is driving this revolution. We're teaching machines not just to think, but to become. These are the first generation of living machines, integrated, resilient, and aligned with nature's principles. With robotic partners that grow and evolve, we can tackle grand challenges from space exploration to disaster recovery. The future we're building is one of hope, capability, and partnership between humans and living machines.